Source code management is a very important engineering concept. The software known as Git is the most widely used tool for the purpose of source code management. Make sure you do not enter a job interview unfamiliar with Git, given its popularity in the industry. Start using Git as soon as possible. Learn to master it. You'll be surprised at what an edge it can provide new developers in job interviews. Despite its importance, students often confuse terms associated with Git. Specifically, Git, Git Bash, and GitHub are related but often confused. I want to help clarify the confusion by defining the role of each of these things. Think of Git as the tool that tracks your project history. Git Bash was created for Windows to provide Windows users with a Linux-like terminal experience. The Git Bash software package actually contains Git software. GitHub is nothing more than a website that hosts Git repositories. GitHub also provides collaboration features. In this lecture, I will also cover authentication to allow Git operations on remote repositories hosted at GitHub. Git is the version control system itself. It was created by Linus Torvalds in 2005. That's the same person that created the Linux kernel. He created Git to manage the Linux kernel's massive and fast-moving code base. Git stores snapshots of your files, supports quick branching and merging, and it works locally without any internet connection. It provides the ability for multiple collaborators to simultaneous changes they may make to a code base and then merge it together seamlessly. You may be aware of the clumsiness associated with multiple people making changes to Office documents such as spreadsheets. Git helps developers overcome those struggles. It allows you to also revert back to a known good state in case a mishap of the code happens. You can use Git from the command line or with graphical tools, but the fundamental ideas are the same regardless of which approach you take. My advice is that you learn Git using terminal commands. If you are a Linux or a Mac user, you're already probably familiar with how to use the terminal, and installing Git is very straightforward. On Linux, you just simply use your package manager. For those of you guys that are using Red Hat variants, such as Fedora, Rocky Linux, or CentOS, then you'll probably use the Yum or DNF package manager. For those of you guys that are using Debian variants like Ubuntu, then you'll probably be using the app package manager. There is very likely a chance that your Linux distribution already has Git installed on it. Now, for you Mac OS people, you typically want to install the Xcode command line tools or use Homebrew to install it individually. The key point is that you do not need Git Bash on Linux or Mac OS. You just use your regular terminal with Git installed. Git Bash exists primarily for Windows users. When you install Git for Windows, you essentially get at least two things. The Git command line tools and a Bash shell that feels like a Linux terminal. It will also include the open SSH utilities that you will need to generate and use SSH keys. If you prefer, you can still use PowerShell or Windows Terminal, but you'll be installing a few more components that are already on Linux systems. Git Bash is just a convenient option, not a requirement. GitHub is a hosting platform that kind of sits on top of Git. It stores your repositories in the cloud and adds collaboration features like pull requests, code reviews, issues, continuous improvement, and agile project boards. You do not need GitHub to use Git on your own computer, but it's extremely useful when you want to share code, back it up, or work with a teammate for collaboration purposes. There are other comparable sites such as GitLab, Bitbucket, and a few others. So your Git skills will transfer across different platforms. Now, there are some cases where your company that you work for may not be able to use GitHub due to conflicts of interest. Microsoft acquired GitHub. Some maybe retail stores or whatever else that may compete with Amazon may choose to use Azure. In a similar way with GitHub, people that may be a competitor with Microsoft may not want the conflict of interest of using a Microsoft-owned brand. So they will maybe revert back to AWS Commit or GitLab or something else. Authentication is where many students get stuck. GitHub no longer accepts username and password combinations for authentication for GitHub operations over the network. Most people have opted to use SSH keys to authenticate their computer with GitHub. And to be honest, it's the seamless approach. SSH, once you configure it, there's no more hassle, and it really only needs to be configured once. So this is what my recommendation to you is. Use SSH keys. There are other alternatives, but SSH keys are probably the most secure and hassle-free configuration. An SSH key is a pair of files, a private key that stays on your machine and a public key that you upload to GitHub. In fact, SSH keys are actually used for several different services, not just GitHub. When you connect to something using SSH key, you prove that you have the matching key without the necessary requirements of setting a password. So instead of being prompted for a username and password, your computer effectively handles the authentication through exchanges of the public key. Every machine that you use should have its own key pair. Never share your private key. Anyone that has your private key can effectively become you in a secure environment. So protect it at all costs. Here's a very quick setup that I will demonstrate live momentarily. You'll open your Mac terminal or your Linux terminal or Git Bash on Windows, and you'll run the SSH Key Gen command. This will create a public and private key pair on your computer. You'll then copy the contents of the public key to GitHub. Then you should be all set. At that point, you can test whether it was successful using a brief SSH test command. So let me take a moment to demonstrate how you can generate an SSH key on your computer using your terminal. Windows users, you will need to open up Git Bash. Linux and Mac users, you'll only need to open up your regular terminal. So give me a moment and I will hop over to my computer and I will demonstrate how this works. Okay, so I'm at my computer and I'm going to open up my terminal. Keep in mind, for you Linux and Apple users, you just simply open up your terminal. You Linux folks, open up Git Bash, and everyone at this point should be looking at a screen very similar. This part over here is just my host name, and it's just kind of telling me what this computer is. It helps you keep track when you're doing remote logins to see which computer you're working on. Other than that, it's just basically letting me know what folder I'm in, whatever else. So this part over here will look nothing like that for anyone else. All right, so the first command that I want to issue is SSH-keygen. And then I think on my slide I actually showed that you could add another flag or whatever to where you could specify an email address, or you could specify like a specific type of public encryption, whether it be RSA or elliptic curve. So just to be complete, let me go ahead and add those flags real fast. I add the flags using -T, and I'll specify the type of encryption that I want to use. It's a elliptic curve encryption, in case you're curious, ED25519, and then I'll specify my email address, and I'll say njruss01@louisville.edu. Okay, so good. We'll hit enter, and then it basically asks me, where do you want to save this? So notice that it's trying to put it in a .dot file. This is very common to have a .ssh file. This is where your SSH configurations and all that will go as you become a more mature developer. For the most part, for these things, I recommend that you just hit enter without changing any of these. By hitting enter at each one of these prompts, it'll just take the default one. The default value is whatever's in these parentheses. So I actually wanted to create this one, so that's okay. I'll hit enter. And technically, people do say that a passphrase makes for something to be a little bit more secure. The only problem is that when you start automating some systems and you start having passphrases, some of these automation systems do not provide a human the ability to like type in a passphrase without a lot of cumbersome overhead. So to be honest, I believe we'll be fine. Let's just leave the passphrase empty for now. You guys can do your own research and decide what's best for you. But for the most part, I have not incorporated passphrases in the past. It could be a bad choice, but for the most part, I think it's fine. So I'm going to hit enter for no passphrase. Now, had I entered a passphrase, I would need to re-enter it here. And I am very serious. I would probably not do a passphrase. Even though I didn't enter one, it's asked me for it again. So I'm just going to hit enter to mean that I don't want one. And then you'll see that it generated a public and private key pair, and they have been saved into the .ssh directory. This random mart, whenever you take a cryptography course, you'll learn how these public-private things work mathematically, And what this random monitor is actually doing, it's the OpenSSH library kind of generating all the parameters necessary, but that's out of scope for this course. So what I want to show you is I'm going to clear this off, and I'm going to do a list of my home directory. And notice that there is not a single thing in here that says .ssh, but notice that I will be able to go into a directory called SSH. Okay, remember, this is important. Whenever you have dot files or directories that have dots in front of it, those are kind of like hidden directories or hidden files, which means when you issue the command list, it won't show it natively, but you can make it. You can say, okay, do .star, and then all of a sudden you see that my home directory has all sorts of hidden files. It has something for the history and the .zsh, which is my terminal. You got the VS Code things where it kind of keeps track of a few things. You got the trash. Then you got the .ssh. So anyway, remember, dot files and dot directories, they're hidden. So I'm going to go back into that with my CD, which means change directory, SSH. Now I'm in there. Now when I do ls, you'll see that I have two files. This was already here and I've got it for a special reason. This is more along the lines of something that Unix style systems have. So disregard these. The primary thing is that you'll have two new files. Now, depending on your computer, if you did not pass in that -t ed25519, there's a chance that your computer generated an RSA public key encryption instead of an elliptic curve one. It's fine. Use whatever's there. So you may be seeing this say id_rsa, and then you'll see the same file id_rsa.pub. It does not matter. So let's assume that you did pass in the -t ed25519 flag. What you have is here is your private key. If I was to display the contents of this, I'd be creating a major security flaw for my computer. If someone is able to have your private key, they can effectively become you in a lot of systems throughout the internet, in servers, or whatever else. Protect your private key, well, at all costs. That may be a little strong, but protect your private key. Don't let anyone have it. Don't let anyone see it. Never display it on a recorded video. Nothing like that. But as you see, there's another similar file a similar file that's named very almost identical, except it has a .pub. So remember, this file is the private key, and so this one is the public key. And you can always tell it's public because it puts the .pub at the end of it. So just to be clear, it does not matter who has your public key, because that is something that you would share with anyone, because it's not considered the thing you need to keep secret. In fact, anything that requests it, your computer will hand the public key out. So it's not even a big deal for me to even show you what is inside this file. Okay, so let's see here. I'm going to do cat. Let me erase all these things here we got. So cat means effectively concatenate, where you can like combine files together, or if it's just used with one file, it means that you can display the contents of a file. So what I'm trying to do is I'm trying to display the contents of this id_.pub file. So I'm going to do cat id, and then I'm going to hit tab. By hitting tab, what it means is it's going to auto-complete that, so you don't have to keep texting all the characters one by one. Then I'm going to do .pub, and you see here that this is my public key, and I don't care for anybody to see this, because if you were on a network of my computer and you were trying to ask for my public key, my computer would just hand it to you. It's the private key that you have to protect on your computer. All right, great. So we have everything that we need as far as generating a public and private key. Now, every time your computer needs a public-private key pair, you don't have to generate one for GitHub and then generate one for your cloud platform. You can use the same one, and it's encouraged to do so. It kind of helps key rotation mechanisms a little bit simpler. So now what we want to do is we want to go over to GitHub. So we go to www.github.com. Just as a brief second, let me show you guys. If you were, for those of you guys that are on Windows and you need Git Bash, here's how you can find it. You go to a Google search engine, you type in Git Bash. Remember, everybody, this is only for the Windows folks, not for the Linux or Mac users. You don't need it, Mac and Windows users. This is only for Windows users. You click the downloads. So basically this one right here, it's git.scm. That stands for git sourcecodemanagement.com. You click this, and you will pick Windows. Mac OS and Linux, you guys do not need this. You guys with Windows, you click here. So it understands that I'm on a Mac, so it's going to prompt me for a Mac. Don't download it if you're on a Mac. There's absolutely no reason to. You click Windows, and then you basically install it. It's something very simple, very fast, and it will install Git Bash on your computer, and that's the key. Okay, so that's it. That's how you can get it. Now we're going back over here to GitHub, and what you want to do is sign in. If you don't have a GitHub account, you need to click sign up, of course. Signing up only requires an email address. Good. So what I plan on doing is I may need to pause the video because maybe I don't want my display manager to show everything, but I will take it as far as I can. So I'm going to click sign in. All it's going to ask me to do is type in my email address or maybe my username and then a password. And then when I do it, it's going to ask me to do a two-factor authentication. I don't know what may pre-fill out with my email. Maybe I don't want everything displaying. So if you guys don't mind, I'm going to pause the video, go through the sign-in process, which is very trivial. All of you guys will be able to do that. And I'll come back into the video once I'm signed into GitHub, and I'll do the two-factor authentication, my cell phone, and everything else. So give me a moment. I'll pause the video, then I'll unpause it, and you'll see me logged in. Okay, so as you can see, I'm logged into GitHub now. This is my education version of GitHub. I have two. I have one that I do for my professional software development that I do for corporations or contract work or whatever else. And I have one that I use for like my teaching classes or whatever else. This is my teaching classes one. If you want to see how you get it, you can click this, and basically I'm on the page where it says click your profile, and then there we go. I would like to make a very fast, quick comment about this. GitHub almost serves like a social media page as well. If you're a young developer and you're getting in and you're about to graduate school or you're going through college, I recommend that you be very active on GitHub. Do coding every single day, write some code every single day, push and pull it back and forth. You'll be set. What I encourage you to do is build up this heat map because these little green dots show how active you were on every day throughout the year. So this has been an extremely slow year for me. As you can see, as an educator, it's not a busy year during the Christmas time. And during the summer, we kind of pan off a little bit too. But over the years, I've been fairly busy, I would say. And you get this heat map that just looks really kind of nice, right? If you go in claiming that you're a very mature software developer and you have tons of experience and there's no one as great as you, to quote some people we know, it's going to be kind of hard to justify if you've only got like one kind of faint green dot in the last 3 years. And here's why. When you go work for a corporation, the corporation will actually allow you to bring your private GitHub account and kind of join it up with their system. So GitHub has the mechanism where you can use your personal account and you get associated your personal account with the corporation. So that way, every single time that you do some sort of work, it will show up on your heat map as being active. So even whenever you leave the company or they fire you or you're just kind of one of those mutually agreed situations and you leave, whenever they disconnect your account from their system, whenever they disconnect your private GitHub account from their system to use it, that effectively, by the way, what they'll be one of these things where like you have an organization, you join their organization with your private account. When you leave, get terminated, fired, or come to one of those mutual agreements, they will remove you from the organization. Then you have no more access to their code repositories, effectively. But all the work that you did for the corporation will still be on here, and so you'll be able to show people, I was active. I did a whole lot. I was doing several commits a week. That's very important. Sorry to take that much time to worry about that. I think it's incredibly important that whenever you go in for a job and you start claiming that you're a mature developer, software engineer, it's important that you have something that demonstrates that you're not just saying that. If you're active on GitHub, trust me, I have been the project manager many times on hiring committees for companies. Whenever they hire someone new, they'll invite team members to interview as well, the new candidate. If it sounds like the new candidate knows what he's doing, then everybody's going to be on board with it. Sometimes we have equal candidates, but one of them seems to be a lot more well-versed into like the tools of the industry. And those people almost always win out because that's going to be a lot cheaper to onboard them than someone else. So do at least learn Git. Get this heat map going. Every class that you take, do all your coding and put it on GitHub and get this heat map going. Now you can always submit it however you want to, but do keep track of it. Also, make public repositories so that way you can create code that you can demonstrate to your employers and say, hey, I am a mature developer. Look what I've got. Okay, So what I want to do is I want to actually now associate, now that I've took this long-winded approach, I want to associate this public key that I created over here, this one right here, and I want to put it on GitHub. And this is a very simple process. I click my face, I click settings, I click SSH and GPG keys, then I click new SSH key, and I'll type a title here, and we'll call this Mac Mini Office, right? Just something that describes which machine this is, because if you don't want to start deleting keys and having no idea what they are, because you never know what kind of catastrophe that causes. So give this a name that's going to help you remember which machine it's on. And then what we're going to do is we're going to go over here and we're going to click copy, and we're going to paste that in there. Yeah? Okay, and then I'm going to add SSH key. We go down here at the bottom, all these SSH keys that I've added, and you guys see right here, we got Mac Mini Office. Great, okay? And then some of these keys we use more than others. Some of these are part of automated systems, so they don't get used often. Sometimes they get used very, very often. Okay, so what we're going to do now is we need to make sure that that worked, okay? So I'm going to issue the command ssh-t git at github.com, hit enter, and then if you see that message, it'll have your username from GitHub on there, and it'll say you successfully authenticated. That means that this was a successful attempt. You actually got your computer authenticated with GitHub. So remember, Git is the software that we're using. GitHub is just a place where we're going to use remote repositories. So we're going to have to make sure that GitHub can authenticate the Git software on your machine so that when you push remote repositories to GitHub, it knows that it's coming from your machine. A lot of words, I get it. Try to study up on that. Hit up ChatGPT, have it explain it to you. If I didn't do a good job, please make sure that you're comfortable with this. Now, I do want you to say GitHub does not provide shell access. Typically, you cannot do anything by SSH. SSH is typically a tool to where, like, if there's a server in an AWS cloud in Virginia, I can sit in my office in another state, SSH into that computer, and then I can have a terminal access to that computer as though I'm sitting in front of it, but I'm at a remote location. GitHub doesn't really have any reason to provide that. All this is doing is just making sure, since SSH is kind of the protocol for the public-private key authentication and the transfer of files, where they just provide this as a tool to let you know this endpoint or this ability to reach out as a test to show that your computer can be successfully authenticated with GitHub. All we're saying, they made this available so that way you could test it, so that way you don't have to wait till something important's happening to find out that something's going wrong. Okay, that pretty much demonstrates everything that we need to do as far as getting your GitHub account associated with your computer. All right, so give me a moment. I do want to introduce some of the common GitHub commands to you. I would like to show you that, at least kind of the basic workflow of the Git command, so at least you have that under your belt. So give me a moment, and I'm going to leave my computer, and I'm going to go back to my slideshow. So one moment. Okay, so as promised, I wanted to show you kind of how the typical flow for a GitHub, for a Git interaction would go, right? What are the common Git commands? So here's the daily workflow. You first clone into your repository to get a local copy. What that means is someone has a remote repository out there, whether it be yours or a colleague's, and you want to bring it in from the remote GitHub location. You want to bring it into your local computer to start working on it. That's what we mean when we say clone. Now, the way you clone it is you get the URL endpoint from GitHub. I'll demonstrate this shortly. You go to your repository, get the URL endpoint, or they provide it to you. You then make a local copy by cloning it on your local computer. You then edit the files. Then you can run something called Git status to see what you've changed. Once you get your changes ready to be like added to the remote repository, you stage them using git add. And then you do git commit with a clear message about the changes that you made, something that will make everybody aware of what you did as kind of a quick glance. You finally push the changes to the repository. Your teammates will then be able to see your changes. They won't even have to go to the remote repository. What they can do is they can issue a command called git pull. What that will mean is all the changes that you pushed to the remote repository can be pulled in by your colleagues. When teammates update the project, they will push their changes, and then guess what you will do? You will then issue the command pull to pull in the changes that they made. This is how collaborators and coworkers stay in sync, not being in the same office or using the same folders or the same files. This is a very powerful tool. With SSH keys configured, those pushes and pulls are seamless. You do not need to do any username, password combinations that are cumbersome. Two-factor authentication is typically not an issue. All you have to do is just issue push and pull, and your computer will handle all the necessary requirements through the SSH libraries to authenticate your computer with the remote repository. Now, admittedly, there are occasions where a merge conflict resolution is required. That's where multiple people are changing the same file in roughly the same places, and that can be a little bit of a hassle sometimes. And depending when you got new developers on a team, it can actually drive you mad, because sometimes there are conflict resolutions with a new person on the team. Before they get into the flow of everything, it can be a little bit difficult to get them up to speed, but it takes time, and we're all here to learn, right? So what I would like to do is I would like to take a moment to demonstrate the straightforward Git commands. There are a ton of Git commands. I mean, there are numerous things that you could do with Git commands. There's a bunch of them, and they work alongside other terminal commands. They also can be compounded together with flags. Every Git command almost has a new flag, so it could be quite a learning curve. But let's take a moment to at least learn the staging, the committing, the pushing, the pulling, and let's see what we can do with that, okay? So if you don't mind, let me pause this video for just a moment, and I will go back to my computer and I will demonstrate the simple Git commands. Okay, so we have left off just kind of when we stopped having the computer earlier. So what I'm going to do is I'm going to pull up the terminal, because there's one more thing that we probably should do. I like to kind of keep things organized, so I'm actually going to get out of this .ssh directory, and I'm going to, let's clear this off, and I'm going to show you that my directory right now is just this. My home directory just has desktop documents, downloads, libraries, movies, music, pictures, public, and that's it. What I want to do is I want to create a folder that's going to hold all my GitHub repositories. So I'm going to say make directory GitHub. And I think this is common. Now let's suppose that I really want to be organized. So maybe I'll create a directory where I say make directory CSE, I don't know, let's do something like 220, right? I'll do one for the course. So make directory CSE 220. And then what sorry, you know what? I made a mistake. Remove. This is how you remove a directory. It's very kind of risky to use REM in Linux. CSE 220. Let me remove that because I actually want to go into my GitHub folder, which I did not do. Now I want to make that directory CSE 220. I know I could have moved that folder. I just want to demonstrate the remove command. So now you see that I have this directory. So I'm going to go into CSE 220. Now at this there we go. So at this point, you see that I'm in a folder that I created for my course, and so all of my assignments are going to go into this directory. So I'll clear this off so we can have a fresh screen to look at. Now, there is one thing that I need to add to make sure that GitHub, the remote repository, knows my name. So right now, all it has is kind of my email address, but you know, I kind of just generate my public key with that. It's not really paying that much attention to that. So I need to at least set my username, my name, and my email into the Git configuration on my computer. The way I do this, and if you don't do this and you start pushing code, it may complain saying, hey, you need to set your name and your email at the very least. Okay, that's fine. Here's how you do it. And this is something that everybody needs to do for the first time only. Just like we only need to create the SSH keys and associate it with GitHub once, after we do this, we won't have to do any of this again. Git config -- global user.name, and here I'm going to put Nathan Russell. Okay, I'm going to put Nathan Russell. And what that does is it tells the Git software that anytime that I make a commit to the remote repository or locally, it needs to associate those changes with the users whose name is Nathan Russell. You can make it up. It's not checking against anything. This is just kind of like you doing it for your own benefit. So git config and then -- global user.email I think is another one. So I will do this njruss01 at louisville.edu. Okay, hit enter. There we go. So we have all that set. Now, remember when we did SSH key gen? We never have to do that again because we only have to do that once on every computer we're using. After we do it once, we don't have to. These two commands, we only have to do them once. We'll never have to do those again. So let's clear this off. At this point, I got all my configurations for Git, at least the bare minimums, all set up. So I'm going to go over to the GitHub page, and I'm going to create a remote repository. Give me 1 sec. Okay, I'm going to go to the browser. This is where I left last time. I'm going to click my face over here, and I'm going to click repositories. I'm going to click new repository, and I'm going to type in a name. I'm going to say lecture video demo on the config, right? So as long as I'm in my account, notice that you have all the organizations that you got, but I'm going to select my own account here. Lecture video demo config. As long as there's no other repository named that in my account, I'm good. They just have to be unique. I always put a description to start off with. I'm going to say this is the repo I created for my lecture video. Sounds good, right? Now here, public. Sometimes we create code that we want the world to use because we want them to brag on us. We want them to say, I like it. We want them to say they follow us. We want all these great things. That's fine. Leave it public. You'll be the only person that can write to it, but anybody can download it or use your code. If you don't want that to happen, you can select private. And then you get to select who gets to see it and who doesn't, but the public in general cannot. So I'm going to leave this as public in case you guys want to look at it. Start with a template. Okay, here, if suppose that I want to create a repository, but I have another repository that's like a template. Like I keep creating like assignments for my students, so I have a template that outlines those assignments. And so I could actually click this down button and select the template. And so when it creates the new repository, it will be filled with some files that are already like a template format. So I don't want to do that here. Add a README, just like when you develop code, you always want to have a README. This README kind of makes it simple. It's kind of like your initial file. It'll be readme.md, which is Markdown, which whenever you look at it, GitHub will display it kind of like a web page, but it's in very simple Markdown format. Git ignore file, this means that it's going to be a dot file, which means it's typically hidden, but it is there. Anything that you put into the git ignore as far as a file name or a directory, that means that those files on your local computer will be ignored and will not be sent up to the remote repository. If you create a Python virtual environment, you don't really want those files to be put in the repository because they're typically huge. If you're creating binary files using the compiler for C++, everybody that uses your code has got it compiled on their computer anyway, so you don't really want those compiled binaries being sent up, so you can choose to ignore those. So let's pretend like, I don't know, I'm going to maybe put Python code in here. I'm not, but I can select a template. What that means is all the typical files of Python like venv, you would basically already have it pre-filled out if you select one of these templates. So Python, it'll have the virtual environment names and all that to ignore. This license, whenever you select public, sometimes you want people to give you credit for what you did. So you could select the MIT license, the Creative Commons license, or whatever. Those are just licenses to let everybody know that if you use your code, they have to give you some sort of credit. Or you can label it as proprietary, means they're going to have to pay you. So whatever the case is, you can select that license here. Typically, there's a whole lot of licenses that are already created that you can select from a list. You see them. You see the GNU public license, like the Linux stuff. You have the MIT license. You have the Creative Commons, whatever. So we create a repository. Sorry about the long-winded explanation, but I felt like it's worth knowing. The first thing that you get is you get one file in here called the git ignore, and you click it, you'll see that it's basically filled with a bunch of things that are typical of Python that you do not want to be sent up from your local computer. See there, it thinks of everything for you. If you didn't do this, you'd end up typing most of these out anyway, so it's handy. Then it created the README file. Now, do you see how this is kind of displaying down here? Whatever's in this README file in the Markdown gets displayed right here. It's almost kind of like the splash screen for your repository, and it also describes how people can use your code in your repository. It's like the documentation. Now watch what happens when I click on it. By the way, you can edit files directly in GitHub. Notice that whenever I do the editing, look at how it actually is. So whenever you have one hashtag, that's a big header, 2 hashtags is a smaller header, 3 hashtags is even smaller, and this is all referred to as GitHub's Markdown format. Markdown just allows you to create a very simple formatting that gets displayed in a nice, neat way on the repository. So what I'm going to do is I'm going to say, I want to create this. I'm going to say, we'll call this lecture demo, and then I'll say, I created this for my lecture demo, and then I'm going to say additional comment. I think this is very cool. And you could even do like a list. You could say item 1, item 2, item 3. So just to give you an idea, I can commit these changes directly, and then here we go. So notice that whenever it displays it, when I go to code here, it's displaying what was in my Markdown file, but it kind of renders it in this nice, neat little thing where you have this is a header, this is a paragraph, this is a smaller header, this is a paragraph, and then I have a list down here. Okay, so that's just the basic overview of Markdown. I know it took a little bit of time to do that, but I feel like it might be worth discussing. So all I have right now is basically a remote repository, and I don't have anything on my local computer. So let me go ahead and click this down arrow, and typically this is the one that's already like selected, but you want to click SSH. HTTPS is fine for getting repositories, but when it comes time to write to them, it doesn't work out so well. So you have to do HTTP, so we need to use SSH instead of HTTPS. So I'm going to click this, and all that does is this is the URL endpoint that I was talking about to clone. This is kind of like the address in GitHub for my remote repository. So I could either highlight that and then copy and paste or copy it, or I could just click this button which copies it to my clipboard. That means I can paste it. So I click that, get the green arrow, that means it's copied to my clipboard. I then go over here to my terminal. For you guys on Windows, this is your Git Bash. Linux and Apple folks, this is just your terminal. So the first command that I issue, now notice right now that there's absolutely nothing in here. When I do ls, it doesn't show anything. I'm going to issue the command git clone, and then I'm going to paste that URL endpoint. That's the SSH version. Now what that's saying is I'm going to clone the remote repository onto my local computer, which means it's going to take everything that's on the remote repository and it's going to bring it over. You typically only have to do this once, unless you delete the directory, and then you have to do it again. But typically you only do this once. And what that means is it went to the remote repository and it has now brought it into my local computer. Recall what this repository was called? Lecture, video, demo, config, whatever. Notice now that when I do ls, which was empty, now has a directory that's named identical to my remote repository. So I'm going to do cd, which means change directory, lecture, video, demo, config, and now I am inside that. Clear, I'm going to list the files. Notice that all that's in there is a README file. That's not quite true because remember there's a hidden file called gitignore, so I will do this, ls.star, and if you look, you see where you got the .gitignore? Okay, great. All right, so what I want to do is I want to demonstrate now how to stage, commit, and push things to the remote repository. First, what I'd like to do is, you see that README? Maybe I'm on my local computer and I'd like to change that. Remember, all you have to do is type in the RE and then hit tab and it'll auto-complete it for you. So I'm on a kind of a terminal-based text editor called Vim. So I'm going to make this change. I created this for my, I don't know, do you guys mind if I say this? Because I'm kind of new to content creation. I want to kind of sell myself here. So I'm going to say for my very, very cool lecture demo. Does that sound okay? And then maybe I will say, I'm going to create a numbered list now, numbered list, and I'll put like first item, and then I'll do second item, and then third item, and you'll see how this gets displayed. And then I'm going to put down here, I absolutely love Git Yes. Okay, so I'm going to save this. Okay, now watch what happens when I do git status. Git status is basically giving feedback of what has changed since I have cloned my repository. Notice that it says I have modified the README. I don't want to stop there. I'd like to create a new file. So I'm going to say vim new file. Yep. And then I'm going to put, here is my new very cool file. Save it. Now look what I've got. I've got a new file that I created and I modified README. So when I do git status, it's just showing me what has changed. Notice it says I have modified README, and then it says untracked files. Untracked files basically means that I have created a new file. Okay, so let me clear all this off. So we have git status, and that's what it looks like. What I want to do now is I've decided that I love what I have done, and I want to push it to the remote repository so that way my friend Sam can look at my changes and brag on them, right? So I'm going to say git add. Now the next thing, I could actually do these things one at a time. I could do git add readme, then do git add new file, and basically what this is saying is I'm staging these files. Let's suppose that I just want to do everything instead of doing them individually. I could just do period. Git add period. That means stage all changes. Now when I do git status, notice that the color is going to change. It now says these are staged to be committed. They're not committed yet, but they're staged to be. A modified README file and a new file called new file text. Okay, so now what I need to issue is I need to issue the command git commit, and then -m is a message I'm going to put, here are my great changes, right? All I'm going to do is put a message there to let my colleagues know kind of a general idea of what I did. Maybe I could say I update the style sheets. I did some grammar checks, whatever it is I want to put there. It just should be a very brief, meaningful message. So then I hit enter. And notice that it says, here are these changes, whatever. Let's be clear about what's happened now. Typically when you have Git, what you want to think about is you got a local repository that you cloned from the remote one, but you still have a local one. Then you have a remote repository. They are completely disjoint from each other until you synchronize them by pushing or pulling. So right now, my local repository has changes that are not on my remote repository. So typically what I would do is I'd issue the command git push. Now, if this is the very first time that you have pushed to a repository, it may complain, and I'll show you the complaint. It may or may not happen, but we'll see. All right, so it didn't complain. Typically, it might say you need to do git push origin and then give you some sort of instructions. What you will basically do is copy that suggestion, then paste it, then do that. That will only need to be done once. Now, notice what I just did. I'm going to do git status. Notice that it says nothing is changed. Nothing. So what that means is that my local repository and my remote one are now in sync. My local repository does not have any changes that are not on the remote one. Okay, great. So I'm going to go over here to my remote repository, looking at the browser. I'm going to click code, and I want you guys to notice that some changes are here that were not there before. Notice that I clicked, this is for my very, very, very cool lecture demo. I added that. Notice I added the number list, and also notice that I changed the new file. Yeah? Okay. So you see now that I have pushed my changes to the remote repository. Now, let me say that perhaps, I don't know, let's see. Maybe what I'm going to suggest is that my colleague, Sam, needs to make some changes that I suggested. But she's going to do that on her local computer, and then she's going to push it to the remote repository. And this is going to happen, and then I'm going to come in the next morning, and at that point, my remote repository will have changes that were pushed by her that I don't have on my local machine. So let me pretend like that's happened, because I could edit files in the remote repository. So what we're going to do is we're going to pretend like Sam made these changes. Notice that my commit messages are here. I'm going to say, let's change this file. I'll edit this file and I'll make a change, and I'm going to put, here is a change made by Sam. Okay, we'll commit these by committing. We're still doing the same thing, except we're committing it directly in the remote repository. click this, don't worry about that, code. Now, what I also want to do is I also want to create a new file that Sam has created. So we'll go here and we'll put Sam's new file.txt, and I'll put here, this is a new file created by Sam. Great. Commit the changes. Now, what we have is a remote repository that contains a new file, and it has a new change to it that Sam did maybe the night before. Now I'm coming into the office the next morning, and I say, okay, git status. All right, so I have not got anything on my local machine that's changed. That's good. But I know that Sam may have made changes. So what I'm going to do is I'm going to issue the command git pull. Notice that what's happened is the Git technology has made the changes on my local computer to reflect the remote repository. This is not the same thing as just making a copy of it and deleting what I have and doing it. It's actually altering the changes in the way that Sam altered the changes. So it's very fast. So if you had a massive amount of files on your repository, but you only made small changes, only small changes would be happening in what they call the fast forward. Okay, so in the git pull. So now what I'm going to do is I'm going to do ls. I'm going to do cat. Look here. We now have Sam's new file. We have the README, and then we have the new file. So I'm going to say cat new file, and notice that here's a change made by Sam. Now this is on my local machine. She pushed it from her local machine up to the GitHub repository. This morning I came in and issued the command git pull, and then when it pulled it in, it made the remote repository, or made my local computer look exactly like the remote repository. So all that's really great, right? So the first question is, everybody's like, man, I really don't know about the command line. I would like to see a graphical interface. No problem. Here's how you add a graphical interface. Here's how you can use VS Code, and IntelliJ is relatively the same way. You'll go up here to VS Code. Notice that I don't have any folders. You'll click File. You'll click Add Folder to Workspace. So let's assume that you have cloned. Let's assume that you have cloned the remote repository in GitHub. So remember, it was GitHub, CSE 220, and then here's my repository. You don't add folder files. You add the entire folder that represents the name of your repository. You click Add. Yes, I trust Nathan Russell. Good. So we have it now showing up over here. Notice that we have the git ignore file that had all these things in here. By the way, VS Code shows the hidden files. And notice that little emblem right here. That means source control, typically GitHub emblem, or I'm sorry, Git emblem. And then notice that little emblem is right there too, because git ignore is considered a configuration file for Git. All right. Notice the new file says here's a change made by Sam. Notice that README is kind of like this, and then Sam's new file. Now there's something I want to show you. Here's what I'd like to do. I am going to now edit this file, and I'm going to say something like, I really do mean that I love Git software, or SCM. Let's do that, SCM. Right? Okay, so I made that change. Now notice what happens when I hit Control S or Command S to save the file. Watch this icon over here. Okay, what does that mean? That means that one file has been changed that has not been staged for a commit. Let me go up here and just add another thing. I'm going to say, instead of the number 2, I'm going to put the word 2 here, and then in here I'm going to put the second item, and then I think this is maybe very, very, very cool. And I want to show you something. This is what we refer to as the diff. Click this thing right here, and then click the file that has been changed. So all the files that have had a change to it, actually I'll just make another change just so we're clear. So right now notice that there's only one file that's been changed. I'll go back over here and I will open this one. Here's a change made by Sam. That is a great change, Sam. Great idea. Okay. Now I'm going to save that. Now notice right here it says 2. That means 2 files have been changed without being committed. So I go here. Now this is what we refer to as the diff. I'm going to click on New File Text. Notice this green. The things in green means that they are additions to the file that have not been committed. Notice on the README file, notice that things in red means they've been deleted. Things in green means they've been added. So notice that this 2 was removed and the 2 was added with the spelling. Notice that second down here, this was removed, and then second was here. You use diffs later on to do merge conflicts changes to see what needs to stay, what needs to be edited, to merge conflicts between two developers when they've pushed. That's for a later date. And then notice who we have in green in here. So when someone refers to as the diff, this is what they're saying. It's kind of a visual thing to show what has changed in the file. Now, let's suppose that I like my changes and I'm ready for Sam to see them. What I can do is I could click the individual files. Remember how I said git add period or git add in the file name? That's what that would do. Or I could go up here and click this one plus sign that says stage all changes. That's whenever I was going to do git add period. So I click that, all my changes have been staged. I'm now going to commit a message and I'm going to say, here is my demo VS Code commit. Okay. I'm going to click commit, and then what I'm going to do is I'm going to say sync changes. Technically, sync changes does a pull and a push, so you could do this. You could say push. All right. Well, that didn't seem very eventful, but let's go to the remote repository and take a look at it. Notice now that the commit messages, this was my initial commit. This is the one that Sam's file did. And here's what I just did. Notice that this was 17 minutes ago, 6 minutes ago, and now we have now. So here's my demo VS Code commit. Notice that when you look at it, it has these changes. I changed this from a 2 as a number to the spelling of it. I changed this from the spelling to the actual number. And then I added some other things. Notice that they're now here because I pushed those to the remote repository. Great. Now let's suppose Sam creates a change again. I know this is getting a little bit tedious. Let's suppose Sam makes a change. Let's suppose Sam changes the README file, and she's going to put here, I like spelling versus number, good job, okay? And then here we're going to put like, maybe we should do this too. Now this is kind of silly because we probably should be writing code. I'm just showing this as text files because I don't want anybody to confuse this with coding and just general like Git commands. So let's suppose Sam has committed this and she has pushed this from her local computer, and now the remote repository looks like this where we got this thing added and this thing added too. So I go back over to my VS Code because this is the graphical interface. I'm going to click my source code management icon. Then I'm going to click, guess what, pull. When this happens, notice that I've seen a diff for a moment that showed the differences, and then look at what the README now looks like. So even without closing or reopening the file, when I did a pull, I now have the changes that Sam pushed up to the remote repository now on my local computer. So we have the terminal-based commands where we do git add, git push, git status, get all these other things. And then we have the visual graphical interface using the VS Code. All right, and this graph, it kind of shows you what's happening. Now, this is very elementary stuff. You need to be working on your own quite a bit to be learning Git, merge conflicts, all these things about how to revert files. You'll probably be doing it in some of these capstone projects later on. But for right now, I just kind of want to give you an idea. Notice here that it also gives like a blame. Sometimes you can install something called a blame, a git blame. So that way, whenever you hover over something, it will actually show you who made the changes, because all these changes are technically in configuration files for Git. So if you have git blame enabled on VS Code, you could actually hover over lines of code to see who actually made the change. Like this one may be Nathan Russell made this change. I look here, it'll say Samantha or Sam. Good. All right, so it looks like we've demonstrated the basic workflow for GitHub. I know it's a little bit of a long video, but I really wanted to make sure that you guys understand that and that you have a leg up on it. And I do appreciate your attendance, and thank you so much on that. So if you don't mind, I will head back over to my slideshow. I will wrap this conversation up, and then I will wave goodbye to you, and we will have another lecture on another day. And from here on out, we'll probably be doing a lot of work on GitHub repositories. And most of my lectures, at least for the coding lectures, I will be making heavy use of GitHub and Git technology for version control. I typically provide students, my students, with code, and they are stored on remote repositories because it helps me distribute better. I basically just hand students a link rather than sending out a zip code that has to be updated occasionally. It's all good. So give me a moment and I will transition back over to um, my slideshow and then we'll wrap this up. All right. So just to be clear, I am kind of new to creating these lecture video contents. So if some of my things look a little bit jerky or whatever, I apologize. Hopefully I will get a little bit better at this as we move along. So thank you for your patience. So just to kind of wrap this show up, Git is the core technology. Git Bash is a Windows convenience that includes SSH tools and things that allow you to connect all in kind of one software package. And it also gives you kind of a Linux experience terminal that you can use. And I very much encourage you to use Git Bash if you're on a Windows machine. For you Apple and Linux people, not necessary. You already have the Open SSH tools probably already installed. You can use your terminal as it is. And all you need to do is use your package manager to install Git if it's already not on there. Okay, now GitHub, it's a very popular hosting platform for remote repositories. There are several alternatives, but for the most part, count on GitHub being the most popular. It also has other integrations like GitHub workflows that you'll probably be exposed to in your future career, to where whenever people make a push, it will kick off workflow actions that will engage in build scripts that will propagate your code to the servers that's going to be running your code. Typically, like maybe make a change for a native app or you make a change to a website. Whenever you push, it'll activate a GitHub workflow action that will actually propagate the changes to all the servers. GitHub, keep in mind, no longer accepts username and password combinations. So you'll probably have to use SSH keys by default. And this is not necessarily like a cumbersome thing. Almost all mature developers have already utilized SSH keys because we typically get in a hurry. Time is money. If you have to keep typing in complicated username and passwords to satisfy InfoSec, it becomes very cumbersome. So remember, SSH keys, you don't have to do any of that. You basically just use the Git commands and GitHub and your computer will handle the authentication just fine. All you have to do is do that initial step of creating the key pairs and associating your public key with GitHub. Now, there are other mechanisms for sure. We can have tokens, but as long as you have SSH keys, I wouldn't suggest making it harder than it needs to. When you go work in industry, your employer may have other requirements, and you'll have to follow that, of course. But for the most part, SSH keys are kind of the modern way of doing it, no matter your employer or you're a student or you're just playing around. Okay? All right, so to be clear, I want to thank you for watching this lecture. Thank you for your patience. I know it was a little bit long. I encourage you to leave helpful comments. Those will help me as I create other lecture videos. If you found this lecture video helpful, then please provide a thumbs up, a positive one, and I look forward to hearing from all of you. And I do hope that you found this valuable, and I hope it will add to your life as a developer. Thank you for watching. I appreciate your time, and I will see you on the next lecture. Have a great day.